You can begin today's lesson by trying the warm-up by determining the vertex of each of the three functions that I've given you here. Now just be mindful of what format that I've given each equation in, and that should help to direct what method you're going to use to help you find the vertex. So try that, put this on pause, try it, and then you can watch the take-up.
Okay, the first one is given to you in the vertex form, so right away we should be able to state the vertex. Switch the sign on the 4, you get positive 4, and then you get the plus 11 as your y coordinate. For the second one, I chose to try factoring, and I did find two numbers that would work, the negative 4 and positive 7 down here. And because it's a simple trinomial with a 1 in front of the x squared, I know I can go directly to the factored form, and my x-intercepts or zeros are at 4, 0, and at negative 7, 0. And then I took those two values and subbed them into, or found the average of those, so added them together and divided by 2 and got a negative 1.5. So that negative 1.5 right here is my x-coordinate of my vertex. And then I took that value and substituted it into the factored form to solve for my y-coordinate. So my final answer, my vertex was negative 1.5, comma, negative 30.25. And you can always check that on Desmos, which I did this time, and it does work out. Now part C, I did try to factor it, and I ended up with a sad face down here because this one did not factor for me. So what I did was the partial factoring method. I let my y equal the y-intercept, so I can at least find 2 points that are horizontally across from each other. And I found the 2 points would be 0, 10 and negative 2, 10. So I find the midpoint between those two zeros, which is negative 1. So that's my x-coordinate of my vertex. I subbed that into my original equation and I got a 9. So my vertex is at negative 1, 9. So all of these equations, these three examples, well, the first one's already in vertex form, but B and C could actually be written into their vertex form now that we know the vertex. So for part B, grab the pen here. For part B, I would have y equals, the a value was 1, so it still is a 1, and then I would have bracket x, take away a negative 1.5, which becomes a plus 1.5, all squared, and then a minus 30.25. So now that we have the vertex, we can actually write it in its vertex form. Likewise, part C, I'm just going to squeeze this underneath here, we would have y being equal to, again, the a value is a 1 in the standard form, so it's still a 1 here. I could write that as an x, take away negative 1 would be plus 1, all squared, and then a plus 9. So we're going to learn a new process that will allow us to go from standard form directly to the vertex form in just a few steps. And that process is called completing the square. Now we know that perfect squares are anything that can be written as something with an exponent of 2 on it. So for example, in part B, when I wrote my vertex form, this piece here has an exponent 2 on it. It is a perfect square. And likewise in part C, the x plus 1 to the exponent of 2 has become a perfect square. So we're going to do a job where we actually work on completing the square. Now you've already done some questions like that in terms of a question could have been, what value of k will make each a perfect square? And I believe I assigned some of those types of questions a night or two ago for homework. So I would like to write that in here right now. I'm going to write a couple of examples in here and then we'll talk about that. Okay, so what I've written in here is that a perfect square is anything that can be written with an exponent of 2. So for example, I have written 9 because 9 really is equal to 3 squared. So 9 can be written as something with an exponent of 2. Another example is this x squared plus 4x plus 4. That is a perfect square because I can write that as something to the exponent of 2. Our job here now is what value of k will make each one a perfect square. In other words, we would be able to factor it so that it is something plus something or something minus something to the exponent of 2. So let's see what we have here. We know that there was a relationship when we did these questions before, when we did some factoring. We know that if we were to square the first, we get the first term. So x squared gives us the original x squared. To get the middle term, we talked about that being twice the product. So if I take x times positive 2, I get 2x's. If I twice that or double that, I get my 4x in the middle, and then we square the last. If I square the 2, I get the 4 on the end. So our job here is to figure out what value of k is going to make this a perfect square. Well, we know the relationship here between this 4 and this 2 is that I could take that coefficient of 4 and cut it in half, and that will give me my 2, and then that's the number that I would square to get back to this 4. So I'm going to use that here to help me do what I need to do. I'm going to take half of this 6. If I take half of it, I get 3. So in my bracket, I should have an x plus 3, all to the exponent of 2. The 3, when I square it, would give me 9, so my k would have to equal 9, so that this would actually factor as a perfect square. Try that with part B for practice, and then we can talk about that. Okay, if you did part B, you should take half of negative 10 and get negative 5. So your bracket values, inside the brackets, you should have an x take away 5. The k value will be the square of that 5. 5 squared would be 25. So k equals 25. So this is the process that we're going to use to help us do this thing called completing the square, which I'll do on the next slide. Okay, we're going to convert this into its vertex form by completing the square. Now we already have the vertex form because this was example C from above. So let's go through the process. What I'm going to do is I'm going to take what I have as my x squared and my plus 2x, and I'm going to ask myself, what would I have to put with that to make this factor as a perfect square? So I'm not even considering that there's a plus 10 on the end. I'm just going to pretend it's not there for the moment. I do copy it down, but what I would do is I want to take half of that value of 2. So I'm looking at this part here, y equals x squared plus 2x. To make this into a perfect square, I would need to take half of the 2, which is 1, and then I'm going to square it. Well, 1 times 1 is just 1. This is a value that we're going to add, but I can't just go changing an equation by adding something extra. So I'm also going to subtract it because the net worth of plus 1 and minus 1 is a 0, and I still have the plus 10 that's on the end. So my original equation and what I've written here on this line is equivalent. If I put both of these into decimals, they'll give me the exact same graph. My net result of a plus 1 and a minus 1 is 0. So this part I've underlined is 0. I'm still left with my x squared plus 2x and plus 10. Now the reason, you might think that's silly, but the reason we're doing that is so that these three terms here will factor as a perfect square. They will factor as a perfect square. So that's going to be my next step. I'm going to actually factor that using my factoring skills. We're going to have an x. Half of that middle term would be a 1. Take the sign from the middle and put a square on the outside. So if you check that, square the first, x squared. Twice the product, 1x is the product, double it would be 2x's, and square the last. Positive 1 times positive 1 is positive 1. So the stuff that's in the green up above, whoops, wrong color. So the stuff that's in the bracket here, up above, that is all of this. It's just in its factored form. What I'm going to do next now is take this part and combine those. If I have a negative 1 and I add 10, negative 1 plus 10 would be plus 9. So all of a sudden, I've gone in 2 lines from the standard form into the vertex form without all of that other stuff that we did before. This was a fairly simple example in that the a value, the number in front of the x squared, is just a 1. And to take half of 2 is easy. It gives you a nice whole number. Sometimes it is possible, especially when you get into grade 11, that when you take half that middle term, you're going to end up with fractions and having to going into decimals. Decimals aren't too bad, but sometimes the decimals aren't nice decimals, and then you need to leave them in fractions, and then it's a little messier. So I would like to do some more examples with you on this, but I'm also going to summarize some steps here below, which I'd like you to copy down, and then we're going to put it onto our next, we'll do the process through our next video.
Okay, so our steps for completing this square is to common factor a out of the x squared and the x term. Now I didn't do that on the example above because the a was just a 1, but I could have divided both of the first two terms by 1. Then we found half of the coefficient of the x term, so we took half of the 2 and cut it, and then we squared it, which gave us 1. We added and subtracted that value inside the brackets. Then we grouped the first three terms because they formed my perfect square. I put the green brackets around it, and I moved that subtracted value outside of the bracket. I didn't have to multiply by a because I would just be multiplying by 1 in this simple example above. And then we factored and collected like terms. So that's what we're going to do on our next examples.